Previously on Stat 201.
Hey Brian, what's up?
Hey Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!
Hey everyone, Jason here. We've tried to find someone to do the Kahoot. You know what though? We could just try and bring him back. I happen to have this. So let's see what happens.
We are back! Back now, back with audio, no sound. We had sound off there for a moment. We can hear us now. So can they hear us? We can hear us. Look, we didn't, Jason had to snap again to bring the audio back. Snap of the audio. So we had to snap two things back there. Snap Brian back, snap that sound back. So awesome. Is it very staticky? How's the audio check, everyone? Is the audio check doing all right? We got 173 people in the Kahoot. Back and better than ever. Stats 1, Laura, thank you very much. Well, thank you very much, Emily and everybody. We're just having fun here. We're just doing stats. We're just doing reviews of everything. So wish I had hit that audio button there. Everything's set up except, oh, we'll double snap on that audio. So remember, the code for the Kahoot is in the Stats 1 webpage on the Kahoot. So your teacher should have sent you some intro for that. How many people we got watching live right now, Jason? What do we got live?
We are 201.
201. This is our first time with over 200 people watching live. So thank you very much. Thank you guys and gals for the intro right there, that you're enjoying it. So you I like it. We're trying to put this out to all 201 students. We'll start the Kahoot in just a little bit. So I'm going to talk a tiny bit about the exam right now. With the exam, it's so interesting. There we go, all these crazy things going on right here. But with the exam, the biggest thing right now is there's exam videos posted, and also we're going to do the Kahoot tonight. So make sure not to put the Kahoot code in the chat, so very much. Just remind everyone that. But with the Kahoot, we're going to practice all of our material tonight. Along with that, you need to know some very important things. We have videos posted on this channel that go over all the questions on the practice exam. And I've been helping make this exam for about 8 years. So realize that the practice exam is a very, 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 very good way to learn the material. So please look at the practice exam material and make sure you have it down. The practice videos are up. Watch them after tonight. I'm really going to highlight a lot of your knowledge that you need to know. So any last questions here before we get started? And remember, you can tag me in the chat. Thank you for everyone. We're live on the internet right now. Usually we have these unlisted, but you can tag me with this. Don't send the link in the chat. Just make sure, because we want to make sure we have it just posted here. And awesome. So good stuff. Thank you for everyone hitting like, if you're hitting like. So good stuff. Any last questions? If you send the code, you get snapped. I like that. Thank you very much, Ashlyn. Thank you guys very much. Oh, they're putting random codes in the chat. You can delete that, but don't worry. 200. Wait, do we have 200 likes? No, they're asking for that. I don't think so. Oh, you guys are cracking me up. So, with this in mind, are we ready to start the Kahoot? I think we're getting ready for it right now, right? The biggest thing is going to be starting the Kahoot right here. Like or leave. You guys and gals ready? We're starting the Kahoot. Get the code in there. Get the code ready to start the Kahoot. So let's get started. Okay, I'm going to start the Kahoot here, so get ready. We're starting. and we're going to hop over to Brian on the screen with the Kahoot. So now we are starting the Kahoot. I'm going to have to move myself around right here. Move around, Brian. So we got a quiz question right here. Which of the following graphics can be used for bivariate categorical data? We're going to pause after a lot of these. I'm going to go right above this right here. So a lot of these questions, I'm going to give away the answers to. So which of these can be used for bivariate categorical? Bivariate means two variables. Categorical being questions like, do you have a cat? Do you live in Tennessee? All these things are categorical questions. So we need two categorical variables being shown at the same time. So let's see if we know what these graphics are and which ones they would be. And some of them have longer answers. Let's see if people got it. And yes, nice job. So let's make sure everyone knows. Please ask questions in the chat. So if you see, and if you are watching along, we're reviewing every question. There are prizes if you win the Kahoot. So if you win the Kahoot, take a picture on your screen and then send it to me, and I will make sure that you get your prize. We're going to give away some Starbucks gift cards, $10 first place, $5 second place, $5 third place. So you only need the one answer, because remember, contingency tables and mosaic plots are both bivariate displays of categorical data. So we have contingency tables, which are the numbers, and mosaic plots. Everyone do this right now. Let's pause on this question for a moment here before we move on. Take out pen and paper. Have your pen and paper out and take notes on each question, because I designed this Kahoot in a way that we're covering topics for each thing that we're doing. So does everyone have their pen and paper out? You should take a note that when it comes to bivariate categorical data, we are going to use a contingency table or a mosaic plot to display them. With that in mind, take the notes. Make sure the biggest thing is not just winning the Kahoot, it's making an A on the test. Who here would love to win the Kahoot and make a 0 on the test? This is not the way. It's the $10 Starbucks gift card is not worth the 0 on the test. So with all that right there, we should be, this video will be live after. Will this be allowed to come back to the Youth Kahoot video? Yes. So with this in mind right here, have the key stuff right here. You're going to do it? Yeah. Good, awesome. So with this right here, let's continue on to the next question. Now, once we do a question, I will be going over the answer, and I'll also be explaining the concepts behind each question. So make sure to ask the questions you have. Let's hop right into that next question. We got a bunch of Kahoot ninjas. Hopefully they go away. Let's cross our fingers on this one. Let's continue on to the next quiz question right here. What percentage of track runners are expected to, what percentage of track runners are expected to run a time of 2:90 or higher? So with this in mind right here, there we go. Let's move Brian out of the way. 2:90 is going to be right here on the graphic. Now what you need to do is you need to look at where the z-score would be for that. The z-score for this one is a z-score of -2, and think above 290. We're going to talk over how to do this, so people should got a lot of Kahoot ninjas in here. We're going to fix that. It's the one problem. Wow, there's a lot of right answers. These things are apparently very good at answering. Let's hope they just are random. So with this, I want to talk about how this problem is solved. This problem right here, we need to practice our numbers. So you ready? We're talking about 290 right here. Now everyone pause and take a big note. When you are doing the normal curve on the test, you need to put the percentiles on it. We need to do the 68, 95, 99.7. So what we're going to do is we're going to go here, and in between here and here is 68. And then the next time, we're going to go out to 95 between my hand all the way over here. That's where 95 is at, and 95 goes all the way up to here. So remember, in between -2, which is down here, -2 and +2 is 95% of the data. And everyone's saying 2 in the chat. Feel free to chime in and answer questions along with us, because the important thing is to know how we get these answers. When you get a curve like this, put the z-scores below it. So now go ahead and look. If this is where 95 starts, then what would be below here? So if 95 is between -2 and +2, that means outside of there would be 2.5 on either side. So does everyone understand that right here as we're talking through this? It's a little bit hard to do on this visualization now, but if I'm having 95% in my hands, I might have to get even bigger for this one. But if I'm here and I'm holding in my hands 95% of the data, so this is 95, what would be outside my hands? If 95 is inside my hands, what is outside? It would be 5%. Then what is one of my hands worth? 95 being inside, 5% would be total outside, and that means above here, I'm mirror imaged on this, being above here is 97.5 because below here is 2.5. So if below here is 2.5, and kind of look, do you see below my hand as though you were to shade that in? If you were to shade in that area down there, that'd be very small. So that'd be 2.5 of the area below my hand, and thus above my hand is 97.5. Remember, go down here, 68, 95, 99.7 for the 3 standard deviations. Make sure to draw on the curve and use the information we give you. Now, we'll say this, I've got some additional help that we're going to be posting, and I might make some additional videos probably tomorrow night to help you review concepts like the normal curve. So make sure to take the code off. If the code is on the screen, what is the point of not saying it? Oh, is it on the screen now? Oh, no. Shh. I don't know if they can join. Sorry about that. Sorry about that. That's my fault. So with this in mind right here, let's hope things didn't go too haywire. So we've got the Kahoot ninjas in there. How are they doing it? We'll cross our fingers. Remember, we're doing this for knowledge, and hopefully those Kahoot ninjas. Which of the following is not a way to describe quantitative data? Which of the following is not a way to describe quantitative data? So there are 3 ways to describe quantitative data. There are 3 ways to describe quantitative data. We have shape, we have center, and we have spread. So the 3 ways to describe quantitative data would be shape, center, spread. So the way that we would not describe quantitative data would be, you got it, form. Now if I have a guess, these things are probably random, so we might see them falling off right here. I don't know, Serena, either. We'll just ignore them for the moment here, and we're going to keep reviewing the concepts. Remember, have your pen and paper out and be reviewing each one of these. Remember, univariate quantitative data, we're going to ask some questions to the chat right now. When it comes to univariate quantitative data, that means one variable, and the variable is quantitative. So what would be a univariate quantitative question we could ask? Univariate quantitative question. What would be a univariate quantitative question we could ask? A univariate quantitative question. Age. Age is one right there. Oh no, Emily, I'm sorry about that. How many, remember, univariate quantitative would be like GPA, height. So these are all univariate quantitative questions, and then we could describe the shape of it, the spread of it, and also the center. So we have shape, center, spread. And remember right here with this histogram, this is number of pets people own. This is a unimodal histogram that is skewed to the right. We'll have more questions on this. Each one of these have been things that we want to make sure you know for the test. So make sure you know what a univariate quantitative question is. Univariate quantitative. You guys ready for the next question? Let's do it. The amount of Cody, if you're in my class, you get 1,000 points right there. Yes, darn the Kahoot ninjas. We'll chase them away eventually. They're gone for the moment. There we go. Let's continue on right here. I'm going to try to make myself out of the way for the question when it appears. So I'm going to go down here so I'm out of the way of the question. And let's continue on. Question now. On the standard normal curve, what percent of area is below +1? So we need the area below +1. So what area is below +1? So this is your 68, 95, 99.7 rule. So with this right here, 68 would be between. So then we do the trick that outside is 16 in either hand. And then if 68 is inside and then 32 is outside, then we think about what would be below +1. So below +1, 68 in between, 32 outside, and then below here should be 84%. Nice job. So thank you for all my mods in the chat. The percent below +1 would be 84. No, Ryan, we'll get you there. Great job. People doing an excellent job of realizing how this works. Let's talk about this right here. Once again, we were looking at the 68 rule that between here, remember this will be up later so you can see me doing all this right here, that between here and here is +1, there we go, +1, which means outside here is 32, 68, 32. That means below is, above here is 16, and below here is 84, because 16% is above here, and 84% is below here. So that's what we want to make sure we're understanding, the percent of area on the normal curve. Very, very important here. Thank you, Joe. Great to have you here. We're going to answer all the questions. If you have a question in chat, especially if you don't know how I solved a problem, feel free to ask, and we will explain how to solve things like the normal curve, correlation, and all the other questions we are covering on this test. So let's continue on here to the next question and move me out of the way to prepare for it. So here we go. Next question, agile line and yellow snail and knowing hair, all in the lead. Quiz question, which of the following is a field we can edit in a pivot chart? So think about your project, and which is a field we can edit in the pivot chart. So let's look at this right here. We have the columns, we have the rows, we have the filter, we have the values. Wait a minute. Column, rows, filter, values. Kind of sounds, we're working on Twitch, we're going to get there. So we almost have Twitch up and going. Column, rows, filter, values. The answer is all of them. These are all things we can edit. And I notice a lot of people put the values because the value field is the thing we'll put in first. With the value field, we actually choose what we want to display. So the value field setting is very important. Like on your project, you were doing the average amount people work. I know someone like, which button do I press? You just hit them all like that, and you're just like, well, there we go, I got it right. So all of these are options. When you think about your rows and your columns control which variable goes on the x and the y axis, and then your columns, like when you're making your table, your filter is how you remove stuff. Great question, Serena. We've got a few videos up on how to use filter. Let's say you want to remove seniors from your analysis, but you want to look at GPAs by like people's, let's say, what state they were born in. So state they were born in would go into columns. You could put the state someone was born in into columns, and then the value would be GPA. So these are examples we need to understand. And then maybe you want to remove people who are seniors. So you could take and filter out, basically this one right here, you could filter out based on class level. So think about examples like this. The variables you want to divide stuff up by go where? I want to see people responding in the chat. The variables you want to divide stuff up by go where? Either one of the two spots. You can divide stuff up based on the what's and what's where you put it. Let's see it in the chat. Yes, we got Ninja's out of here. Well, Ninja's a good guy, but kind of the x and the y, columns and the rows. Mohammed, nice answer. Kind of your x and y. That's your x and y of this. When you think about your x and y, which I might have said earlier, that's your rows and your columns here. And then what you're actually showing is the values. And then if you have an additional variable that you want to remove or kind of filter on, you can put it into the filter, and the filter will be what you're removing on. So the rows and columns are literally like when you look at a table has rows and columns, and then you can put numbers inside of it, like average GPA based on where someone was born and maybe their socioeconomic level. So you could do that right there, and you could make a table of that, and you'd be viewing the average GPA based on these categories, and then you could say, well, I don't want to view seniors for whatever reason, and you could filter out seniors. So think about what each one of these does and how it helps make a pivot chart or a pivot table. So great job and great answers in the chat. Remember, I am watching the chat live as we do this, so any questions you have, we're hitting upon some key concepts in this Kahoot, so ask those questions and we will answer them. So I'm gonna move out of the way here. Let's see who's winning first though. It is Agile Lion still in the lead, and I'm blocking those scores. So we see Agile Lion, Yellow Snail. For anyone watching the countdown clock, there's a sort of streaming lag, so the question will be timed out. I think the lag is pretty decent right now. Yeah, don't watch the countdown clock on the stream. I think we're about a 3-second latency. So thank you very much for that comment right there. It is a small latency on the screen, about 3-4 seconds. Next question, is the following residual plot good? Now remember, residual plots should show no pattern. Oh, I just kind of gave it away. We only got 30 seconds here, but residual plots should show no patterns. And so with this in mind, this is the chapter on regression. So if you're listening in close, you'll know that a residual plot should look nice, and let's talk about some key aspects of it. This residual plot you're seeing over here is actually good. I'm going to give away these answers as we're talking about it, so especially if you're watching the video, you can better understand why people are answering, yes, it shows no pattern. That is the good thing for the residual plot. We should see that answer up here. We got it. So a good residual plot is one that actually, remember, we talked about this a lot in my class, the line would be at 0. because if something has a residual of 0, that means it's on the line. So this line of 0 right here on this residual plot is actually a good thing that it's actually at 0. That's because it'd be flat. A residual plot is when you take your plot and make it flat. Now you'll notice we don't see an issue, and I want to see, oh, they're already saying in the chat, they're already saying the plot does not thicken. So if you look over here, you'll see that it has kind of the same thickness. And what do we mean by that? All the way down here at the bottom, here's the bottom down here, and all the way up here at the top, here's the top up here. It's about the same thickness as you go through the plot. If you notice thickness here, and thickness here. We don't want it to be any thicker or thinner at different points. Now this is going to help you out for later. There are 4 conditions. It's trying to crack you guys up there. We have 4 conditions on this. We have the QQ straight enough, no outliers. And so the residual plot can show us straight enough, outliers, and all those conditions. So QQ straight enough, no outliers. Angela, 1,000 points. We're just throwing some extra credit to my students right there. So QQ straight enough, no outliers, all that good stuff right there. So you want to make sure it shows no pattern. Sorry there, Roland. So we will continue on right here. QQ straight enough, no outliers, plot doesn't thicken. We're going to review all these concepts today. 7th place, amazing job. Remember, we got Starbucks gift cards for the winners. Quiz question here. Which of the following phrase helps us identify identifiers? Now, identifiers are a unique thing. An identifier is something that can only be one time in a data set. So if you were to identify someone, you wouldn't really use their name. Be like, oh, my friend Brian. Well, that could be a lot of friend Brians. I might be good down here. Hopefully I'm blocking answers. But you might say, you wouldn't tell someone their social security number, but social security number would be an identifier. Driver's license would be an identifier. What would be another identifier in a data set? And think about, so hopefully, did we trick some people? Nice job. Which one is an identifier? Because it identifies which one we're talking about. So when we do identifiers, give me more identifiers in the chat. I said driver's license, social security number. What else is an identifier also? Student ID number. Nice job, Jade. Student ID number also right there. Zip code kind of can be. Zip code is a little bit categorical. Zip code is kind of more of an idea of a category of people who live in a group right there. So zip code is kind of a categorical variable. So with that right there, we get so all that good stuff. But FedEx package number, Rachel, and also Kate, great answers. License plates are identifier, order numbers are identifiers, birth certificate numbers, things like your social security number would be an identifier, all these things that cannot and will not repeat. If it cannot, will not repeat. So take this note right now. An identifier is something that cannot, your cats wait. An identifier is a variable that cannot and will not repeat. Great examples of this would be things like your social security number, your license plate. So right here, we got Streamlabs helping mod 2 right now. So let's continue on right here. We can go on to the next question. And we see here Purple Lark is leading the way. And so let's continue on right here. It'll be like, yes, write the regression model. I need to get out of the way for this question. Write the regression model right here. So the regression model right here, what do we have with the regression model? What do we have? Now the important thing to note is you need to take the slope and the intercept. And I will be reviewing this here in just a moment, that we need to be writing the regression model right here. So what should you do? Everyone is wondering, how do we do this question? This is a tricky one. So what do we do? Nice job. I see a lot of people got it correct. That is amazing. Let's review how to do this. I'm going to hop out of the way and let's talk about these key concepts. Now, I don't think I have questions interpreting these right here. Why is both x and y weekend text? Oh no, did I make an, oh no, oh, I think I made a typo in my answers. It should be weekday text. Oh no, Adriana, nice job pointing that out right there. There is a typo in that answer. It should be weekday text. Sorry about that. It should be weekend text, and weekday texts are the y variable. So, and you guessed and you got it right. Good job if you guessed and you got it right there. So let's take a look. What numbers do we have right here? Very important, work with me on this, that when we look at these numbers, we need to see here that this number right here is the coefficient, let's point to it. This number right here is your what? Who can tell me in notation what that is? Specifically, 1.3 is what in notation? 1.3 is what value in notation? B1, nice job, answers in the chat. That is B1, which is the coefficient of the slope. And then if you notice right here, we can go up a little bit more to this, and that is B0, which is the coefficient of the intercept. So if you can identify the coefficient of the slope and the coefficient of the intercept, you should know, and I'm going to write it here in the chat for everyone to see, that we have y hat equals B0 plus B1x. So with this right here, we have here that the predicted value is equal to the intercept plus the slope. So that's what we have going on right there. Know how to write the regression equation, know how to use these estimates that we have the slope and we have the intercept right here. Are there any questions on how to write this one? Sorry, it should be weekday tax as the y. I know I put x and y as the same thing. It should be weekday tax, which are explained by weekend tax. Now let's pause on this question, because I don't think I wrote some of these. Who can interpret in the chat? Is there a hat on the y? There is. It should be y hat, and it won't let me put those special characters in the chat. So who here can tell us the interpretation? So this, let me write this in the chat. Weekday tax equals, and then it would be 115.5 plus 1.3 times weekend tax. So right here, who can tell me what we have right here? We have the regression equation written out properly this time, and also we need to interpret the intercept and the slope. Let's do the interpretation of the intercept right here. What would be the interpretation of the intercept? If there is no weekend tax, the expected number of weekday tax would be 115.5. When someone sends 0 weekend tax, that is correct. We expect them to send 115 weekday tax. Great job. This is the practice you need. You need to know how to interpret your slope. You need to know how to interpret the intercept. If you're watching this video, pause when we try to ask you to interpret stuff and then try to type it out yourself. How about the interpretation of the slope? Once again, take a moment and try to think about it. The interpretation of the slope would be, for each 1 unit increase in x, we expect y to increase by b1. So for every weekend tax, the number of weekday tax increases by, and I think that's correct, and you are correct, people typing out, for each additional weekend tax, we expect the weekday tax to increase by 1.3. Let's add an additional question to this with r squared. So we'll get some amazing grades on the test, because we don't always ask, but r squared is maybe 0.80. What would be the r squared interpretation here? How could we interpret r squared in context of the problem? So think about this, with r squared being 0.80, what does that mean? So 0.8 what? What does that mean in context of the problem? So, and great, they're still answering. Now be careful, Mohammed. We want to make sure that r squared is not r. Good answer. But remember, r squared is percent of variation explained. Great practice right there. 80% of the variation in weekday tax, which is y. And so let's put this right here in the chat. R squared percent of the variation in y is explained by the variation in x. So there it is with the blanket interpretation. The other one was when x is equal to 0. Let me put this before it. Intercept. When x is equal to 0, we expect y to equal b0. And then the slope was, for each 1 unit increase in x, we expect y to increase/decrease, don't say them both, by b1 on average. So, and r squared would be, so it's blank percent of the variation, so it's right there. Will there be a class on Wednesday before the test? There will be. We will have class and we will be reviewing before the test. So make sure to come to class review. We'll be doing some last minute review. Does this all make sense right here? Practice your interpretations, have them written down. Here's one of the things that I worry about sometimes is my Pearson usually gives you a selection of A, B, C, and D for choices. But when you get to the exam, usually we have you write out these answers. Look at the practice test. It's a good example of what it might be like. So great job on these questions. Let's continue on to the next screen right here. So we are doing, best superhero. Oh no, I put them out of order. Who's the best superhero? Is it Batman, Spider-Man, Iron Man, Wonder Woman? Who is the best superhero? I wonder what you guys are going to say. I changed the order of the questions. I should have done them more because there's a little bit of a logical order, but I clicked the random order. Spider-Man is GOAT. So Spidey. New Spider-Man movies have been amazing. This is our mid-review break right here for just a moment. So we can just relax and just Batman all day. I agree. I've got my Batman watch right here. You can barely see it on camera, but that is a pretty good tie between Iron Man, Spider-Man, Wonder Woman, and Look at those two ties. So this graphic right here is a what? What graphic is that right there? This graphic over here is a what graphic? What kind of graphic are we underneath right now? Not really a pivot. What kind of graphic is this up here? Categorical univariate, correct. And what does categorical univariate make? It always cracking me up. Bar chart, Jordan, you are right. That is a bar chart bar graph. And bar charts and bar graphs, great answers too, are univariate categorical. So it is a univariate categorical question. Realize I asked you one question here. I said, who's your favorite superhero out of these choices? And then we displayed it in a bar chart. So it's not, and really great answers. This wouldn't really have a skew. We just kind of talk about kind of the most common and least common groups. And so think about how you could summarize this. We have two very popular heroes right now. We have Iron Man and Spider-Man. And then we've got the next tier of Wonder Woman and Batman. And what's interesting to me is they're both kind of even. It's Spider-Man and Iron Man kind of even, and then Wonder Woman and Batman are also kind of even. Now, the big thing is this wouldn't really be bimodal because remember, we could mix up these bars in any pattern. It's just that there's kind of two most common groups. This here is univariate categorical as opposed to the one we saw earlier that had modality to it, which is univariate quantitative. When you have a univariate quantitative question like your GPA, your height, your weight, those are all shape, center, spread. When you have a bar chart like this, you kind of have the most common and least common groups. Great job, Adriana. Great answers in the chat. Good way to remind people, just review the material here and all these little things. I do understand why people might say that looks bimodal, but bimodal is for univariate quantitative data. Everyone loses their extra credit. You don't vote for Batman. We had that one time when I was supposedly freaking out. I'm gonna move out of the way here again. Great answers. Hopefully I don't have to jump out of the way every time. So Agile Lion, great job. So let's continue on right here to the next quiz. What are possible options to add to a pivot chart? This might be an easier one. We've got data tables, data label, chart tables, axis title, all these things right here that we could add, and you guys probably know where this is going. These are all the things that you can do under the plus option. We'll probably do this question a little bit quicker. And we've got a lot of harder stuff coming up here. But go ahead and hit the answer really quick, because the answer is you can pretty much add anything to a pivot chart. I talked to so many people. There we go. Nice job, Streamlabs. Streamlabs bot in the chat doing its thing. So with this right here, we got chatbots. Got it going on. First appearance of the chatbot. See, we don't usually need chatbot, but we got them there just in case. So with this in mind right here, we have, oh, really? Oh, it's funny. Sorry, chatbot's a little anxious. It tries, chatbot tries. So with this right here, we have data tables, data labels, all these things right here that we can add to make everything, chatbot's taking mod. Wait, did it count you wrong? All these should be right answers. They've all got checks on them. So it shouldn't count you wrong, at least unless the Kahoot's doing something crazy here. Let's hope not. Cross our fingers right there that hopefully it's not doing something wrong. Yeah, probably ran out of time. Oh no, we might not have clicked the button. Let's continue on to the next question here. We're gonna hit upon some hard questions in this Kahoot. So let's go to some of the hard questions here. Ooh, full screen, there we go. And next question, Agile Lion, Purple Lark. This is a neck and neck race here. Okay, which one is not a condition for regression? Here we are. Guess what's coming up right here? QQ, straight enough. I'll read upon all the easy ones. QQ, straight enough, no outliers, plot doesn't thicken. Which one is not a condition? Oh, there we go. But there's one that's on there. I'm basically giving it away. I want this in your head. QQ, straight enough, no outliers, plot doesn't thicken. I thought it was one of those easy ones again. Hopefully I didn't trick anybody. It says not a condition, and I did say that, so uh-oh. So it says, my brain has thickened from this class. Refresh the YouTube page. Great job. Let's talk over these conditions and see what they mean. And thank you to everybody in the chat. So let's look at this right here, and let's interpret this also, because I think this will help us out for later questions. So the 4 conditions are QQ, straight enough, no outliers, plot doesn't thicken. I want you right now in the chat to practice, or if you're at home watching this, write an answer to how you would talk about this being quantitative. So how is this quantitative variables? What does it mean for this graphic right here to be quantitative variables? So what would that mean? Who can give a great answer in the chat on how these variables over here are quantitative? What would you say? You'd say quantitative variables, that's the condition. And then how would you say, like give a full elaborate answer, says though you're gonna be graded for it. Both of the units are numbers, great answer. So there we go, hopefully it's working fine. Hours and age can be counted, you can count both X. Now, so both are measured in real numbers, Amelia, great answer. Years and hours are both numeric, quantitative, great answers. Each variables can be measured by a value. I would say both are numbers, both are quantitative values. Age is a quantitative value, weekly hours reading is quantitative. So I would maybe say age is quantitative, weekly hours reading is quantitative. So they're both quantitative variables. What does straight enough mean? Now this line, let's go below the line right here. Straight enough means that this line that I am right over here with now, this line right here, this red line, there it is over there, this red line goes through the data. Now, I know this one might look like it has a little bit of a bend, but does that red line go through the data for the most part? Does that red line kind of go through the data? And we want it to be straight enough that the line kind of, there's a little bit of a bend there, a little bit of a bend, but that line looks straight enough. Now, when we say no outliers, don't be too particular. We try to make the plots look pretty good. This one appears to have no outliers. Now, if there was a point right over, we'll go this way. It's hard being a mirror image of yourself. If there was a point where my finger's at right here, that would probably be an outlier. Even maybe over here, where my finger's at now, that'd be an outlier. But these are not really outliers. They're pretty close to the line. The further away something is, the more of an outlier is. You are allowed to use the TI-84 calculator on the series, on the test, so definitely use it to your advantage. Brian is the outlier. I am the outlier. I'm over here now at the bottom of the graphic. My head is now the outlier. That's probably a good way to visualize it right there. The last condition for regression is plot does not thicken. And you do not want the plot to thicken. You can say plot thickens, but you do not want it to thicken. So don't be like, yay, it thickened, that's a good thing. This one's not perfect, but we'll be a little bit forgiving. If you notice, we only have one point over here, this one point I'm pointing at right there, so I don't really know the thickness of the area because there's only one point. This is about the same thickness here. Does everyone see how thick this is? Like that's the thickness, and then this one over here is right here. That's how thick it is. We're literally talking about how wide it is around the line. So I guess I need to go this way. How wide it is, how wide the points are around the line. So we do not want it to get wider or narrower. We don't want it to do this. It's not just that it gets thicker, it could also get thinner. So make sure you know your 4 conditions. QQ, straight enough, no outliers, plot doesn't thicken. But it's time for another quiz question. Let's see if you can interpret that R squared right there. Who can be the first person in the chat to interpret the R squared, which will come up later in this Kahoot. 94% of the variation in weekly hours readings is explained by the variation in age. Amazing. That was, wow. You were ready. You knew I was going to ask you. He's going down to that R squared. He's going to do it. And you were ready. You knew how to do that. And the biggest thing is, I'm not saying we always ask the same questions, but we want you to know how to interpret quantities like R squared right there. So we want to make sure when we say interpret R squared, it's the percent of variation in Y explained by the percent of variation, the percent of variation in Y explained by the variation in X. Blank percent of the variation in Y is explained by the variation in X, as in 94.07% of the variation in weekly hours reading is explained by the variation in age. Excellent, excellent job. We're going to have more practice here, and that's the whole point of the Kahoot. It is always Y by X in the interpretation. Roland, amazing answer. Thank you, Roland. Keep helping everyone out in the chat. That is our goal for the Kahoot. Next question. Purple Lark takes the lead. So let's continue. X explains. Yes, you guys get it. Can you swap them by turning it to explains? You can do that. And if you see that the grader maybe takes off points, talk to me or talk to your teacher. If you think, I got this right, I just turned it a little different in language, that's all right, as long as you communicate the same message, but sometimes people switch it and then it changes the meaning. So we just gotta make sure we give the right interpretation. Okay, which of the following is not a word or phrase to describe correlation? Remember, there are 4 things that describe correlation. We have, what are the 4 ways to describe correlation? We want the one that is not. We have strength for correlation. That's how tight it is. We were just talking about that a moment ago. We have strength. We have direction, which can be positive, negative, or neither. So if it goes up, it's positive. If it goes down, it's negative. If it stays flat, it's neither. Strength, direction, form, which is either linear or not linear, and unusual features, which means the only one on here that is not is going to be shape. Shape is the only one that's not, because what is shape for? So shape is for something else. When do we use shape? Good stuff to have. When do we use shape to describe data? When we talk about the shape of a data, like if something looks like this right here, kind of that bell-shaped curve, when would we talk about shape for the data? When would we talk about shape? Univariate, quantitative. So univariate quantitative is something like age. So think about the age of people and it's kind of centered around a normal distribution. So we have univariate quantitative, and if we have 2 quantitative variables, it's going to be correlation. So correlation is for 2 quantitative variables. That's why the conditions are Q, straight enough, no outliers, plot doesn't thicken. So when you have 2 quantitative variables, you'll talk about the shape, direction, form, and unusual features. When you have 1 quantitative variable, you'll make things like histograms, box plots, you can make some other graphics, but mainly those are the big ones right there. I'll get Alex in the chat. So when we have univariate quantitative, it'll just be shape, center, spread. And we got some additional questions coming up on that right here. I'm gonna give some big advice at the end. Stay till the end of the Kahoot, even if you don't win. We're gonna have some big advice coming up here at the end. So we've got Purple Lark and Lovely Possum in the lead right there. What % of students are expected to make above a 55? This is a great question, a little bit tricky, and let's take a look. I zoomed in on this graphic. If you notice right here, this is a tricky one and we got a minute to do it. So I'm gonna help you solve this in 1 minute, don't guess too quickly. Above a 55 would be over here. Now, we're gonna talk about how to solve this on the test. Here it is. Mark right here with your hand what above a 55 would be. Can someone solve for me in the chat what the z-score of this would be? Above a 55 would be a z-score of what? This is a tricky one. Negative 1.5, correct. Now I want us to think about this. You might be figuring this right now. If you go here to 60, 60 has a z-score of 1, negative 1, excuse me. And with it being negative 1, above negative 1 has to be 84, and above here has to be 97.5. So the answer is between 84 and 97.5. It's going to be the blue answer. But let's talk about how we got that again. Let's slow it down. I was trying to solve it in the time frame. But we're going to talk about how we got this answer and make it very, very clear how to use the 68, 95, 99.7 rule. So do this. Whenever you get a graphic like this on the test, imagine that this said right here that this is 6% of the area. Let's just round this to 6%. This is Brian's advice for the test. Write this down. This is good advice right here. What would you write if this says 6%? What would you write? I can't show it. There it is. There we go. It's hard doing a mirror image of yourself. If that black area is 6%, what would this white area be over here? What would that white area be? Well, we'll just review right here. So it'd be 94%. But can you imagine if we just flip this graphic around, we just flip it all the way around, and then where would this line be? If 84% is right here, if 84% or 85, the number where my head is 85 is right here. If we flip it around, it'll be over here, right where my hair is. So we'd be right there at 55 now if we just flip the graphic, because this has a z-score of positive 1.5, and this has a z-score of negative 1.5. Does that make sense if you just flip the graphic? And then think, well, wait a minute, that would put the black area, it would be over there, wrong way, over there, and then the white area would be over here, which is 94%. Now on the test, we will probably give you percentages like that on the curve, and we might expect you to mirror image it. But do this immediately, and I wish we could draw on this Kahoot, because immediately what I would do is I'd put a line right here. So on the test, I would take and I would mirror image this, and I'd put a line right here at 55. And if I knew that that was 6% up there, right here my line at 55 would also have 6% on it. So I'd know that this is the 6th percentile at 55. And then above the 6th percentile is 94%. Maybe hit reload on the page, Serena, that might help. Hopefully we're not getting bombarded here. No, Emily. Emily, we'll see where you are at. If you were leading the way, definitely. Sorry, Kahoot is being weird today, apparently. We'll try to improve how Kahoot is done. We've never had these problems. It might have been our ninjas. I don't know if they're trying to figure out who are bots or not. Maybe they're destroying other people's points too. Sorry about that, Emily. Hopefully, I haven't heard many people saying, but Alex and Emily are having small problems. So continuing on here, does everyone understand how to do this problem? Make sure you know how to work the problems in the Kahoot. That is the key. So yeah, we've lost a lot of people in the Kahoot, the ninjas. So let's continue on right here. Purple Lark and Friendly Cat. Quiz question right here, 68, 95. What is the last number in here? I believe we have 68, 95, and last but not least we have 99.7. I put way too long on this one. You should know that 68 is between -1 and +1. 95 is in between -2 and +2. And 99.7 is in between -3 and +3. 68, 95, 99.7. I think maybe some, yep. 68, 95, 99.7 are the three numbers. We'll be using this a lot, and so you should know those three answers. Let's continue on here to the next question. Let's see who is leading the way. What is the best measure of spread? This is a really great question. Look at the distribution. What is the best measure of spread for this data? I really like this question. Maybe it's very, very test relevant, not that any of them are not. But what is the best measure of spread? Now I want to point out some key stuff right here. Whenever you're doing spread, you want to talk about the shape. The shape of this distribution is unimodal, very skewed to the right. It is unimodal, very, very, very skewed to the right. Can we work on the non-whole number z-scores after like finding the percentages? Yeah, we could try it. We could do some of that. Oh, we tricked some people. So good answers, and let's see where people went wrong here. So let's put this in the chat. I'm sorry, I didn't mean to trick you right there. And let's see right here. When data is skewed, let's put skewed right here. When data is skewed, center is going to be median, and then spread is going to be IQR. So skewed, when data is normal, we would have center is equal to mean, and spread is equal to standard deviation. So remember these right here. We're trying to put as many tips in the chat as we can. There are only two measures of center that we really focus on. We have mean or median based on normal or not normal. And then, so this is a measure of spread right here. So for spread, we would either say IQR or standard deviation. So since the data is so very skewed, it's got that extreme right skew to it, or I guess going this way with the mirror image. Since it's so right skewed, we would use the IQR for spread. And so who's Mystery Dove? I don't know, are they leading the way now? Let's find out. So let's go here to the next question. We got Majestic Bunny, Friendly Cat. Good job. Let's continue on to the next quiz question here. Interpret R squared in the context problem. Let's see who can get it. R squared in, oh no. Got to get out of the way of the question answers. Here we go. Blank percent of the variation in y is explained by the variation in x. This is a key tip for another one. I'm going to need to put these to 60 seconds next time. So 94% of the variation in y is explained by the variation in x. 96.94. Put 96 in there. I think I unsquared it. 94% of the variation in y is explained by the variation in x. There's a limit on how much you can write in Kahoots, so the answer looks to be the blue one right below me. 94% of the variation in weekly hours reading is explained by the variation in age. I want to point some key stuff out here. I know we're doing a lot of questions and we're hitting upon basically the whole semester so far. So what should you have in your notebook? I want someone to put in the chat, what notes should people have in their notebook to understand how to interpret R squared in context of any problem? So in context of any problem, how would you interpret R squared? Like, what is a general note that they can take for people watching this video right now that they should have? And they should be like, okay, I need to do this. So explain by X is good. Let's do the full entire thing. I like that there. Thank you, Lindsay. The full entire thing. What do we got? Let's see right here. Oh, that's the equation. Serena puts the equation. We have y hat equals b0 plus b1x. Remember, we always want to do blank percent of the, Alex, amazing answer. Blank percent of the variation in y is explained by the variation in x. Blank percent of the variation in y is explained by the variation in x. Does everyone see these answers right here? And I'm repeating them as we say them. That blank percent of the variation in y is explained by the variation in x. Blank percent of the variation in y is explained by the variation in x. Sorry if Streamlabs comes after people. I think with notation and stuff, I put it in there and it's being, Streamlabs, calm down. It's all right, Streamlabs. Did it go after a mod? Hopefully it didn't. Sorry about that. So once again, remember, we're talking about the variation in y explained by the variation in x. And this is the R squared right here. R squared does not need to be unsquare rooted. Now I want everyone to tell me, how would you know if this is a positive or negative correlation? Go over right here. How would you know if this is a positive or negative correlation? So how would you know that? Looking at the information right over there. So the slope is positive, and that's how you would know the correlation is positive. Can anyone solve for the correlation from this value right here? How could you take R squared and solve for the correlation and then know if it's positive or negative? One, look at the slope. The slope of the line is positive, and so now with this, square root it. Who can do that? Who can square root it in the chat? Let's see if you get it. What is the correlation? And then how will we describe that? So everyone's saying square root. Let's see if you can get the correlation in the chat. Take that R squared and square root it, and then let's see the answers we get. It's always a good check because it sounds, there we go, 0.969. You are right. So 0.969 is the correlation for x and y, which is a strong positive linear correlation. That's a strong positive. If you notice there, we mentioned strength, we mentioned form, and we mentioned direction. I don't know if there's outliers or stuff like that, but it's a strong positive correlation. Cody, nice answer in the chat. If you notice, we're using shape, center, strength, direction, form, unusual features to describe the correlation. Purple Lark still leading the way. I'm going to hop out of the way of the questions once again. Remember, this is a review, so we're trying to focus on all the questions. What percent of students are expected to make below a 60? Let's take a look. Something I want to point out right here is you're seeing a lot of David M. Lane applet. You should know how to look at the David M. Lane applet with the information filled in. Now, if you're looking below a 60, it's going to be a z-score of -1. So here's something, and we're going to talk about this with the question I'm giving you right here. What I would do immediately, if I got a question like this, and I think you could probably about guess the answer. Let's see how many people get it. So, and thank you everyone in the chat. So right here, great job. The first thing I would do if I was doing this question is I would go right here. Do not even look at any of the graphics we give you. Please write this tip down. Take your blank sheet of paper, your formula sheet, and use it as scratch paper. Try to write this out here. Oh no, you thought it said above, I'm so sorry. It says below. And draw a line right here at 60. If you draw a line right here at 60, where should you shade, kind of obvious, to find the percent of people below it? You should shade what? Because you're going to imagine that you draw a line right here where my hand is going. You're going to draw a line up and down where my hand is. My hand's the line, and then I'm the shading. So this right here, I am shading very little of the curve. So if you think about this, if you just look at the answers kind of give away what it is. But we're not here to just get answers right on the Kahoot. We're here to figure out how to answer the questions on the exam. And what you should do is you should draw this out and look at it and say, that looks to be about 16%. So if you do this on the test, often your teachers were right here at 60%, so I need to move my arm over here, and so go straight up with my arm, and there we are. So I am now the shading, and my arm is now the line. This is a very small portion of the curve, and it's not as small as, let's look at some of the answers, it's not as small as 2.5 just visually, and 16 and 25 would be harder to figure out. I just can't think fast enough. Oh, these are meant to be like quick and fun answers, but with that said, make sure to understand how we're solving these. So let's look at a few more right here and practice, practice, practice. So let's look here. Explain the slope in context. This is an amazing question. Explain the slope in context. People should have this down. So it's for each 1 unit increase in x, we expect y to increase by b1 on average. For each 1 unit increase in x, we expect y to increase by b1 on average, or decrease if the slope is negative. For each 1 unit increase in x, we expect y to increase or decrease by b1 on average. So x here is age. So for each additional year, I expect weekly hours reading to increase by 10 hours on average. Which one tricked people? For each additional, it looks like people switched the weekly hours reading with age. So remember, for each additional x, we expect y to increase by b1 on average. Let's put that in the chat again. I want to mention something. I've looked at the exam, and this is public knowledge, but about, I think, many points on it. The two big things on it are regression and also normal. So if you're watching this right now, you should know that the regression portion and the normal curve portion are very important. And I want you to focus in on how I'm teaching these things right now and how I'm making you practice them. I'm having you write or think about what the answers are. So make sure you are writing these answers and understanding how to explain them. So practice right here. For each additional x, we expect y to increase by b1. It's also chapters 7 and 8. Santos, thank you so much. Chapters 7, 8, and 5 are some pretty big ones that make up about 40 to 50-ish% of the exam. So it's easily about like 40-ish% of the exam. So be very knowledgeable of these chapters. They're not impossible, they just take practice. Know how to interpret R squared. Know how to interpret the slope. Know how to interpret the intercept. Know how to write the regression model. Know how to solve the regression model. Does anyone need me to repeat that? I'm going to say it again. Know how to interpret R squared. Know how to interpret slope. Know how to interpret the intercept. Know how to write the regression model. Know how to solve with the regression model. And there are some really great practice questions that we have. So look at the practice videos and practice the questions. Great job. Snorkeling is better. So fun stuff. Let's continue on right here. Purple Lark leading the way. My gosh. On the standard normal curve, what percent is above +2? On the standard normal curve, what percent is above +2? Lots of normal curve questions right here. You have to understand how to use the normal curve. And I'm probably going to pull up some other stuff here in just a moment. So we'll continue on. What percent is above +2? If 95% is in between positive and -2, remember 95 is between, 5% is outside, so above 2, so I got to do this end, would be 2.5. So above 2 would be 2.5. You probably figured that out. A little bit of an easy one right there. So we're going to continue on. And I tell you what, after the Kahoot stay, I'm going to do some harder problems here. So stay in the Kahoot, and we will do some harder problems here at the end, because I want to make sure everyone knows some of the hardest questions. What is the best measure of center for this distribution? The best measure of center is what? You only have 2 possible answers. 2 answers. Can someone put in the chat for me what the only 2 measures of center you should think about? I'm going to write for Hunter right here. The slope interpretation slope for each 1 unit increase in x, we expect y to increase by b1. Thank you, everyone in the chat. For each 1 unit increase x, we expect y to increase by b1. There you go, Hunter, right there in the chat for you is the answer for how to interpret the slope. That's just the general interpretation. Don't write that for an answer. Say things like, for each additional weekly hour of reading, for each additional year someone is older, we expect their weekly hours of reading to increase by blank. Because that age in the previous problem was the x variable, and weekly hours reading was the y variable. Trying to think back. So this one was a little bit easier. Remember, your measures of center are mean and median. And measures of spread, as Olivia points out right there, are IQR and range. So IQR and range are measures of spread, and mean and median are measures of center. So we've got the 2 paired together, median, IQR. Mean, standard deviation. The first 2 are measures for, I think I said median and IQR, are measures for skewed data, and then the next 2, mean and standard deviation, are measures for normal data. So make sure to know the difference between the mean, standard deviation for normal data, and median and IQR for skewed data. Excellent job, everybody in the chat. Thank you for all those amazing answers. We got Captain Badger, new leader in groovy hair. Oh, wow. We've got some new leaders to the game right now. Which of the following phrases helps us identify quantitative variables? So think quantitative variables are a quantity. Quantitative variables are a quantity. So let's think here. Clever bee. There we go. Daring yak. So quantitative variables are a quantity. So how would we deal with quantitative variables? How would we know if something's quantitative? How is it a quantity? And so you could ask someone, what's your height, what's your weight, what's your GPA? You could, it's basically, if you can't tell, it's how much. It's going to be how much is quantitative variables. So it needs to be actual real variables, actual real numbers, like how many hours do you sleep, how many hours do you play video games? These are all quantitative variables, and we would actually put them down as real numbers. Is Rapid Yak rapidly taking over the leaderboard? Let's find out right here. Oh, they are, and Groovy Hair. Wow. Let me move out of the way of the question again. And we're going to do a little more review at the end of this. I'm going to do some tougher questions. Which of the following graphics can be used for univariate categorical variables? Univariate categorical. So univariate, one categorical variable. No, it's all right, Serena, you'll do all right. We have here univariate, which means one, and categorical means a question like, do you own a dog? Or do you own a fox? All these great things right here. So univariate categorical is one categorical variable, and there are two answers here. I'm hoping. Pretty good job, pretty good job. We tricked some people, so it's good practice. Remember, and we talk about this in my class, you can make a pie chart of your favorite bars, and put this in your head or put this in your notes. You can make a pie chart of your favorite bars or a bar chart of your favorite pies. And a categorical question, just imagine a pie chart saying yes and no. So you would have, the percent of people who say yes, the percent of people who say no. And I know percent is a number, but when you ask people a question like, do you own a fox? You're gonna get a lot of no's. You'd be like, someone says yes, and you're like, really? So yes and no is a categorical response to which you can talk about the count of people, which is not the amount, like you're not asking how many people own a fox, you're just saying this many people responded yes, this many people responded no. Catch me out at the So with this right here, pie charts and bar charts are both used to display categorical variables. What is another univariate categorical display when you put a bar chart in order? Who knows that one? If you put a bar chart in order from most to least, I do not own a fox, maybe one day. If you put from most to least, that is a bar chart that's been put in order. That's called a what? Pareto. Jackie, nice answer. A Pareto is a bar chart that has been put in order. So Paretos are bar charts that have been put in order. So great job. And if you notice, a box plot and histogram go together. If you remember from your project, you had to make box plots and histograms, and those are both univariate displays of quantitative data. I should own a daring yak. Yes, I like it, Sydney. Bar chart your favorite bars, pie chart your favorite pies, or bar chart your favorite bars, pie chart your favorite bars. There we go. Oh my gosh, I can't speak tonight. So great job. Captain Badger, Rapid Yak is still on the leaderboard. Let's continue on. Which is the Q3 for the data? We're looking for Q3 of this data right now. Let me move out of the way. What is Q3? Wait a minute, Q3, if I have 3/4 in my hand, how much money do I have? 3/4 in my hand, I have how much money in my hand? I have 75 cents. So if you think about this, we're gonna hopefully show this off before it ends off. This is the minimum value in the data set. Someone owns 0 pets. This is the 50th percentile in the data set of people who own 1 pet, as in it's kind of common. And that right there is the 75th percentile. Now there's something really odd with this data. We tricked a few people. Some people said 5, and I'm glad we did this review question. So with this right here, you'll notice that 5 is right here. This is where outliers begin. So this is not a percentile. It's just everything above here is an outlier, as in someone who owns like 6 pets, 7 pets, so you can trace it down, or 8 pets would be an outlier. If your friend owns 4 pets, that's high, but it's not an outlier. 3 pets, high, but not an outlier. 2 is the 75th percentile. So, oh no, I'm sorry about that, Ethan. I'm sorry that some people will lose. I hope everyone's doing all right on this. I think we're using a lot of bandwidth, so hopefully it's working all right. Kahoots take up a good bit of bandwidth. And we are going to try to make it even better next time, so keep doing it right here. Oh, there we go. So with this in mind, can you identify all the points on a box plot? Now, where are the min and Q1, and what does that mean? Where are the min and Q1 in these box plots? Both of the min and Q1 are where in this box plot? Where is the min and where is Q1 in this box plot? They're both at 0. And just think about that. Is it odd to own 0 pets? I mean, that's, for college students especially, that's the minimum value you can own in pets, and also the 25th percentile, which means 1 in 4 people own 0 pets. And then the 50th percentile would be that half the people own 1 pet or more, and half the people own 1 pet or less, because that's the 50th percentile right there. So 50% is above that, and 50% is below that. That's where the 50th percentile person is. And the 25th percentile, which would be the person who's 25% the way up the scale on pet ownership, owns 0. So there's a little bit of an interesting of a box plot right here, because the minimum, and great question, Hunter, the maximum for this data set is what? What is the maximum for this data set? And it's going to be right over there. The maximum for the data set is 8. So be careful. The end of the box plot is just where the end of the unusual data is. So this right here is the maximum. Those points are outliers, but they count. Make sure to not forget your outliers when you look at box plots, because they do count. And look at what we have right here. We have a histogram, which is univariate quantitative data. So the histogram is how many pets do you own, which is a quantitative question, and it's univariate quantitative. It is one quantitative variable being displayed for how many pets. Let's just go on here and let's do the next question. And now, which way is this distribution skewed? Is it skewed to the left or to the right? And my class should know this. I want to see people type in the chat. We have blank to the something, blank to the something. What is it? So what do we have? What do we have? What do we have? It's something to this, something to this. We should be able to do it pretty quickly. Right to the high, Cullen, nice job. Right to the high, left to the low, whatever way the tail goes. Right to the high, left to the low, whatever way the tail goes. Right to the high, left to the low, whatever way the tail goes. So Serena, good question. The saying kind of confuses you a little bit. When we look at this right here, we would think of this as the tail. Does everyone see, like, if this is a creature? Oh no, it's like me. Wait, I gotta go this way. It's like this is the head of the creature, and then it has a tail going out there. So you follow the tail. The tail is this part right here, like it's a cat's tail. And hopefully we make it kind of clear in which way the tail goes. Does everyone see the tail is going to the high side of the data? So the tail tails out to the high side, and that means the data is very skewed. So the distribution is skewed to the right. Did it reverse? Oh, it reversed the right and the left side on the thing. That's kind of not fair. So right to the high, left to the low, whatever way the tail goes. Excellent, excellent work right there. Let's continue on. Okay, but most of the, oh, thank you. The chants, I like that. So we try to chant everything. We chant as much as we can. Which of the following graphics can be used for univariate quantitative? Univariate quantitative is going to be what? Univariate quantitative. This is one quantitative variable. It's like those graphics we were seeing just a moment ago. One quantitative variable. So we want one quantitative variable. One quantitative variable. We have histograms and we have box plots. Another one of those double answers. Hopefully, oh, we still are. Did I do 3 of them? Oh, I did stem and leaves also. I forgot there's stem and leaves on there. Stem and leaves are also, those are a histogram where you can see the number. I didn't see that there. It's right below me. But we have histograms, we have box plots, we have stem and leaves. Stem and leaves are histograms where we show the numbers. I was about to say stem and leaf. Yeah, those are univariate quantitative displays of data. Univariate quantitative displays of data. Excellent work right here. And let's continue on. And let's do it. Explain the intercept in context of the problem. We got this one. This is one from earlier. So we should know, and I'll write it in the chat, when x is equal to 0, we expect y to equal b0. When x is equal, let's do intercept. When x is equal to 0, we expect y2 equal b0. So when somebody's age is equal to 0, we expect weekly hours reading to be 10 hours. And does that really make sense? Or there we go. When age is equal to 0, we expect weekly hours reading to be, oh no. Oh, I said that at the last second there. I looked at the wrong value. So we want to look at the value of the intercept. I looked at the wrong thing. Even I can get one wrong. Here's the value of the intercept right here. That is the intercept. There's the data again. What you should do on your test, what are we going to write below this? What are we going to write below that on our test right there? If age, what should you write below age so you know what it is? That's your what variable. Age is your what variable on your test. Is your x. What is this? What is the coefficient of age, which is the slope? This is known as what? Because it's for each 1 unit increase. Remember, for each 1 unit increase in x, we're talking about b1. You see how x is connected to b1? So b1 is right here connected to x. So for each 1 unit increase in x, we expect weekly hours reading to increase by 10, because that's b1. Then what is this right here? This one I'm underneath is what? My hand is underneath now. That is the coefficient of the what? They're saying in chat that is b0, which is the intercept. And I want you to think about b0. By saying it's b0, you're saying when x is equal to 0, we expect y to equal, and just look at this. If I were to blank this out right here, if x is equal to 0, then age is equal to 0, and what does this equation read now? Well, since age is equal to 0 and it's gone, now we just have weekly hours reading equals negative 168. So if age is equal to 0, we expect weekly hours reading to be negative 168. So I like it, Natasha, in the chat saying that babies don't read to the point they make their weekly hours negative. So yeah, it makes no sense. One, weekly hours reading can't be negative, and babies don't read. At least I don't think so. So that's an illogical intercept. Know how to read this output. We will not be doing things like r squared adjusted, but r squared, b0, b1, very important for the test. You don't want to say things like the slope is positive or the value of the slope. Be very, very careful. Know how to interpret your slope. Know how to interpret your intercept. Let's continue on. Right here, last 2 questions. Find the IQR, we got this. Remember, the IQR is that box of the box plot. So look over there at the box and tell me, what is the IQR? Oh, it's all right, Mona Lisa. Just take a deep breath during the test and just relax. We got this. Just practice these things. I think this review right here probably covers about, I would say 40 to 50% of the test. There's a lot of questions. I've seen the test, obviously. There's a lot of things I know that are directly related to the test. Like you could be asked, find Q1, find Q3, find the max, find the min. Are there outliers? Things like that, directly related. You could be asked, you know, how do we describe correlation, which is 2 quantitative variables. You could be asked the conditions. You could be asked about, is an intercept logical? All these things right here that we've been doing and we've been practicing and interpreting, you could be asked. So be very careful. Made it all the way to second place, missed the last 2, feels bad. But if you're in second place, you do get a $5 Starbucks gift card. We're almost done. So here we are. It is 2 is the answer because the box right here, we're down here, it goes from 0 to 2. Take this note that the box in the box plot is the IQR. Can you show the examples of writing again when we finish the Kahoot? Yeah, I'll do a few more answers. Great question. And we'll hop over here to the chat screen and maybe I'll cover a few more topics for everybody. Let's do the last question. Let's take some questions. You could be asked to make the regression equation. Is this going to be a regression equation? What is this one? Which distribution has the biggest range? I need to get out of the way quickly. Which distribution has the biggest range? I'm going to go over here. I'm off screen now. Which one has the biggest range? Be careful. Be careful. Be careful. When you look at range, it's max minus min. Be careful. Which one has the biggest range? Be careful. Hopefully someone's going to say, oh no. Be careful, which one has the biggest range? Do not forget. I'm over here, I'm off screen. Oh no, no, don't say that. Oh, it was you, no. How many people did I trick? Why did the last one have to be the trick question? Oh no, we got a lot of people. Oh no. Let's go ahead and show this right here. Okay, so a lot of people said the fort. No, I'm sorry. Oh no, witchcraft. No, I'm sorry. No, I've lost. Everyone is mad at me now. But what do you notice about the one that has the biggest range? It's right down there, and that should show up. It was in the video, so I could see it too. It's hard. It's not impossible to see, but I do admit you always got to look for those outliers because up here to down here is the range. This one has a range of basically 5. very close to it. It's a very large range. So remember, don't just look at the whiskers right here. A lot of people got tricked on that one. But I put these questions in here for a reason. Oh no, exactly. These are in the top 3. Oh no, yeah, that's in the plot. That dot right there is where that's someone who made a GPA of about 0. So you can go get mad at that person. They are the ones who created the much larger range of max minus min, where my hand's at is the minimum, and then all the way up here at the top is the maximum. So very, very tricky question. And we're gonna hop over here and maybe do a tiny bit of lecturing, and I'm gonna take questions from the chat now. So let's see who won. Please take a screenshot if you won of you winning the Kahoot, and then you need to send me it, and then swing by my office hours. I'm gonna go get some gift cards. Lovely Possum, amazing job. Captain Badger, Agile Gazelle. Those are some amazing scores. So has to take everyone to Starbucks. I was like, oh no. So let's hop back here to lecture mode, which we should have. There we go. Oh, I got the portal going again. We'll turn off the portal right there. So how can we tell? I can open back up the portal anytime I want. Is my portal? Oh, is my portal? It's not turning back on. The portal's gone. We should have told everyone today that Kahoot is back. Kahoot is back. I should have done that too. Kahoot is back. It's back, but now it's over. Kahoot is over. So we could watch the crab rave. Everyone in class knows about crab rave. So let's bring up some notes right here. Let me exit full screen on this. You're waiting for crab. I should have pulled crab rave at the start of this. That would have been awesome. What does everyone want to talk about? How many people do we currently have still in the Kahoot? We still have 141, great attendance. Can you interpret R squared in, yeah, let's do that right here. Okay, I'm gonna hop into the notes and let's go right here and let's put in a new slide and I'm gonna write this right here. So we're gonna bring up some notes right here and let me bring up the lecture notes. Boop. All right, cool. And we should be seeing the lecture notes in here. There we go. Okay. So let's do the interpretations. People want interpretations in the chat, and let's take a look at that. So what do we have? We have blank. Oops, that's my highlighter. Let's not use highlighter. Let's go here to, I think the black one again. Blank percent of the variation in y is explained by the variation in x. Be back in 2 seconds right here. That's what happens when I hit all the buttons at once. I can just disappear like this. We can just snap Brian away like that. So right there, just snap away really quick. We got the crash came back. I'll probably let you guys go in a second here, I think. How did you do that? You just snap away, just go. Then you come back in. So blank percent of the variation in y is explained by the variation in x. My handwriting is always not the best. Crab rave. I tell you what, I'm going to try to see how would everyone think. Ooh, what would everyone think if we were to possibly do some review tomorrow? How would everybody like that if we try to? No, don't feel so good. We'll try to do a review tomorrow. Does that sound good for everybody right here? I'm going to try to get the room booked. We'll do more review and we'll go over some practice problems. So I'm going to let everyone go because we've been going since 5 p.m. tonight. It's right about 8. So we're going to try to maybe be online around 4-ish. I'll try to get the room booked and we'll hear back about it. So I'm going to let everyone go. Email me if you have questions. We'll end off here with crash and then the big thing so everyone can see our class crash thing real quick. Here we go. Have a great night, everybody. We will try to do some more tomorrow and we will be doing class again on Wednesday and the test. Have a great night, everybody. Bye.
Yeah.